We're going to be looking at solving radical equations today. Radical equations are just equations that have a variable inside of a radical. That's all that is. And what we're going to do here is just take the radical to the power of the index. So for the first one, we have the cube root. So if we cube that, it'll get rid of the cube root. But first, we want to get the radical by itself. So let's divide everything by 2. So then we have the cube root of 2x plus 7 equals 3. And remember, we can do, as long as we do the same thing to both sides, we can do anything to the equation. So we can cube it. We can just cube both sides. That'll take off the cube root on the left. And on the right side, 3 cubed is 27. And now we can solve this equation as normal. So we'll subtract 7. We get 2x equals 20. Divide by 2, and we get x equals 10. Now when we're solving radical equations, we're going to need to check our answers. You'll see why in a minute. Not with this problem, but with example 3, you'll see why we need to check it. But let's go ahead and do it now and get used to checking it. So by checking it, I mean we're going to plug it into the original function and make sure that it makes a true statement. So if it is indeed a solution to the equation, it should make a true statement when we plug it in. So that's 2 times the cube root of 20 plus 7 equals 6. And actually, I'm going to put a question mark here above the equal sign because we're trying to see whether or not it's equal. So then 2 times the cube root of 27, potentially equal to 6. And the cube root of 27 is 3. 3 times 2 is 6. That checks out. X equals 10 is a solution. Let's look at example 2. Now this one has something to the 3/4 power. That is a radical. So remember that when you have a fractional exponent, the denominator, the bottom of the fraction, tells you the index of the root. So we could rewrite this as the 4th root of x plus 2 raised to the 3rd power. However, it's going to be fairly simple to take care of it just as it is. So we don't need to change it into a radical. You can if you want, but you don't need to. Let's isolate it. So let's get it by itself by adding 1 to both sides. So then we have x plus 2 to the 3/4 equals 8. Now we want that 3/4 to become 1. We want to cancel that off somehow. And so if you think about how to make a fraction become 1, you're going to multiply it by its reciprocal. So we want to multiply 3/4 by 4/3. But we can't just multiply both sides of the equation by 3/4 because it's an exponent. It's not going to cancel with the exponent if we just multiply. But what we can do is we can raise it to the 4/3 power. So if we raise it to the 4/3 power, then we're going to have the power of a power. We're taking x plus 2 to the 3/4 to the 4/3. So we multiply the exponents there. Let me show you how that'll work. So we'll take this x plus 2 to the 3/4 and raise that whole thing to the 4/3. And then we have to do the same thing to the right side. We've got to do the same thing to both sides. So here, using our exponent rules, we're going to multiply 3/4 and 4/3. That gives us x plus 2 to the 1st, which is just x plus 2. On the right side, we have 8 to the 4/3. That's 8 to the 4th, and then the cube root of that. Or again, we can do it in the other order. We could take the cube root of 8 and take that to the 4th. And actually, I'm going to do the second one there. So I like to take the roots first because then you can work with smaller numbers. So the cube root of 8 is 2. So that's 2 to the 4th, which is 16. So we have x plus 2 equals 16. Subtract 2, we get 14. Now, let's check that solution. So we had x equals 14 was what we just found. Let's plug it back in and make sure that we get a true statement. So 14 plus 2 to the 3/4 minus 1, we're going to see if that equals 7. So this is 16 to the 3/4 minus 1 potentially equals 7. 16 to the 3/4, that's the same as the 4th root of 16 to the 3rd. So let's take the 4th root of 16, that's 2, and then raise that to the 3rd power. All right, 2 to the third is 8. So 8 minus 1 is 7. That works. So that means x equals 14 is the solution to that equation. Now example 3, you'll see why we need to be checking these solutions. So we're actually going to get 2 solutions here. One of them won't work when we check it. So we're going to square both sides to get rid of that square root. So we get x equals, and we have to be careful how we square this. It's not going to just be x squared minus 6 squared. We have to FOIL this. So we're going to have to write this out as x minus 6 times x minus 6, and then FOIL. Since you guys are pretty familiar with FOIL, I'm just going to zip through this. So this is going to turn out to be x squared minus 12x plus 36. And then in order to solve this equation, we need to have 0 on one side. So every time that we've tried to solve a quadratic equation, we've had 0 on one side. Remember, finding the x-intercepts means that the y value is 0. So we have 0 equals the thing with x squared and all that. And then we can solve it once we have 0 on one side. So we'll subtract x from both sides. And we get 0 equals x squared minus 13x plus 36. And on this thing, we could use the quadratic formula, or this one is actually factorable. So I'm going to factor because it's a bit faster than using the quadratic formula. Now we're going to look for factors of 36 that add up to negative 13. So two numbers that will multiply to be 36 and add to be negative 13. When I'm doing this, I like to list the factors. Let's see, 3 and 12, 4 and 9, and then 6 and 6. So 4 and 9 will add to 13, but we need negative 13. So we're going to have x minus 4 and x minus 9. And negative 4 and negative 9 do multiply to be positive 36, so that checks out as well. Then we use the zero product property. Say that x minus 4 equals 0, or x minus 9 equals 0. Solve those equations, and it gives us 2 answers. Let's check both of these. So I'm going to take x equals 4 and plug it back into the original equation. So that's square root of 4 equals 4 minus 6. On the right side, we get negative 2. On the left side, remember this is that business with the principal square root, that thing I lied to you about. This is the principal square root. It's only the positive root. So this is positive 2 equals negative 2. That is false. So that means x equals 4 is not actually a solution. Let's check x equals 9. So if we plug in 9, we're going to get the square root of 9 equals 9 minus 6. On the right side, that's 3. On the left side, principal square root of 9 is 3. That works. X equals 9 is a solution. So when this happens, we call this an extraneous solution with 4. So 4 is an extraneous solution. It's something that looked like it was going to be a solution, but when we checked it, we found that it wasn't actually a solution. Let me try to give you a conceptual understanding of why this happens. So I'm thinking of a number in my head. We'll call it x. I'm going to square that number, and I'll tell you that when I square the number I'm thinking of, I get 16. Now, what was the number I was originally thinking of? Some of you may say 4, because 4 times 4 is 16. That's true. Some of you might be thinking plus or minus 4, because negative 4 times negative 4 is also 16. But I'm only thinking of one number here. So the number I'm thinking of is either 4 or negative 4, not both. There's only one number that I was originally thinking of. And the only way that you could possibly know what that number I was thinking of is if you check with me. If you ask me, the person who originally thought of the number, which one were you thinking of? So was it 4 or was it negative 4? So we have two options, but you can't know unless you check with me and ask me which one it was. So that's what we're doing here. So we solve the equation. We get two different answers that look like they could be true, but we don't actually know until we check with the original equation and see which one is actually right. All right, let's do another one of these. Example 4 here. This is another one where we might get an extraneous solution. So we're going to have to check them after we do the math here. So we'll square both sides to get rid of the square root. Again, I'm going to zip through this foiling of the x plus 1. So we're going to get, let me erase that equal sign. We're going to get x squared plus 2x plus 1. And on the right side, 7x plus 15. So the square root just goes away. Then we need to get 0 on one side of the equation. So let's subtract 7x, subtract 15 from both sides. That'll give us 0 on the right side. So we get x squared minus 5x, and then minus 14. Again, we could use the quadratic formula here. However, this one's factorable, so I'm going to factor it because that's a bit faster. We're looking for two numbers that will multiply to be negative 14 and add to be negative 5. So those two numbers are, let's see, negative 7 and 2. That'll do it. So negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. Use the zero product property and solve the equations to get the two answers, or the two possible answers. Again, we're going to have to check these to make sure. And I'll just jump down to the bottom. Check positive 7 here. So 7 plus 1, again, go back to the original equation. 7 plus 1, square root of 7 times 7 plus 15. 7 plus 1 is 8. And then we have 7 times 7 is 49 plus 15. So 8 equals the square root of 64. Since that is the principal square root, that is true. 8 is the principal square root of 64. It is the positive version of the square root. So 7 works. Now let's try negative 2. So we're going to have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So that's negative 1 equals square root of negative 14 plus 15. So on the right side we get square root of 1, left side we get negative 1. Now since that is the principal square root of 1, that's 1, so we get negative 1 equals 1, which is false. So we throw out negative 2, that's an extraneous solution. We're going to skip example 5. That one's more complicated. I don't want to take the time to do that right now. I'd rather give you the time to work on your homework, which is at the bottom. And I'll see you guys next class.